talking about a system of equations. What do I mean by that? It is a system of equations. A system of equations is a system of equations. Thank you.
So like multiple different equations?
A system means we have multiple equations. And the solution is just the point or points that make all of the equations true. If you are able to solve it, so if a solution exists, then that's what we call consistent. So consistent has a solution. If you don't have a solution, then it is called inconsistent. And we will use those vocab terms as we go through. If it has a solution and it's consistent, we know that they meet. In terms of lines, because we're only looking at linear systems today, how many times would two different lines meet? Once. If you have lines, if you plotted them, looked at the graph, this is an example of consistent system. Okay, that point right there is where they meet. The other option is I might give you two equations for the same line. So if I did that, let's say we had this, and then I gave you that same thing again, then it's still a solution because I gave you a system, they were just the same, so every point on that line. But that's the only options with a line. Either it's a single point or it's every point on the line. Inconsistent means we have two lines that never meet. How would they never meet? What would happen? Yes, parallel lines would be inconsistent if they have the same slope. All right, so our options for solving these, you can do it by graphing, but you probably remember from Algebra 1, Algebra 2, when you graphed, it wasn't the best method. Your graphs had to be absolutely perfect in order to find where they met, and if they didn't meet at nice values, then it was hard to tell from the graph. You know, if the point is 1, 2, that's not bad. But if the point is 5/8 and 1/16, that's really hard to tell from the graph. So we're not actually going to use that method. And we're just going to rely on substitution and elimination. So let's try first by substitution and then we'll do elimination. Make sure we remember both methods. Substitution requires what? What would we have to do first if we're going to solve by substitution? We have to take one equation and solve for one variable. Does it matter which equation, which variable? No, not at all. So let's say I wanted to take the second equation and get x by itself. So to do that, I would add my y over, so x is 4 plus y. And then you are going to sub that into the equation we haven't used. So the first equation, instead of x, I'm going to put the 4 plus y. So 4 plus 2y equals 8. Subtract our 4, divide, so y is 2. And once you have one of them, how do you get the other one? You can go back to one of these originals, but the easiest is right here. X is 4 plus y. So if y is 2, then x is 6. And how do we write this at the end? So x, y, 6, 2. This is a consistent system. We got a solution. It's possible if your variables aren't x and y, when you write your order pair, just go alphabetical order. So if I pick different letters, just alphabetical is fine. Questions on that one? Why don't you guys take a look at this one? to solve this by substitution. There's no right or wrong in terms of which variable to start with, but there is probably an easier. Which one would you want? Yeah, I would solve for y in the first equation. That way you don't have to divide. Not always avoidable, but sometimes it is. So y is 5 minus 2x. And then we sub that into the second one. So we have negative 4x plus 6 times the y, which is 5 minus 2x, equals negative 2. Distribute 30 minus 12x. Have like terms, so negative 16x. If I subtract over my 30, that's negative 32. Divide, and x is 2. Don't assume that you're only going to get nice whole number integer answers on these. No, I know when you first learned it, you always got the nice pretty answers, but we're big kids now, so we might get some nasty fractions sometimes. It doesn't mean you did anything wrong. And once I have my x, then I plug it in, so y is 5 minus 2 times 2. 5 minus 4 is 1, so my answer is 0.21. How can you check these if you wanted to? Plug them into both original equations. If I put it in here, 4 plus 1 is 5, negative 8 plus 6 is negative 2. So it definitely does work. All right. Let's talk about elimination. With elimination, let's see. The goal is to be able to add our equations together and to get a variable to cancel. If I just add these right now, does anything cancel out? No. So to get it to work, we have to multiply one of the equations by something so that their coefficients are the same number but opposite. So positive 5x, negative 5x. Positive 6y, negative 6y. Doesn't matter which variable we cancel out. So what do you guys want to do?
I'm thinking just multiply the bottom by 2.
Multiply the bottom by 2. I agree. So the top one stayed the same. Bottom one became negative 2x plus 2y equals negative 3. If we were trying to cancel the y, what would we have multiplied by? Yes, thank you. Yes, if you're trying to cancel the y, you would have had to multiply the bottom one by negative 3. Right, so when I add these, positive 2x and negative 2x cancel. Positive 3y and positive 2y is 5y. 1 plus negative 6 is negative 5. So if we divide, the y is negative 1.
So then we can just plug that in.
Does it matter which one?
No.
Okay, so if I did the bottom one, it's negative x plus y, which is negative 1 plus negative 3. If I add the negative 1 over, that's negative 2, so x is positive 2. And then just make sure at the end you write it as an ordered pair. Alright, I want you guys to try a problem. So, what'd you guys decide to cancel out?
I cancel out y.
Okay. To do that, they're already opposite signs. We have a positive and a negative, so we just need to get the coefficients to match. So 6 and 4 can both be turned into a 12. So we can take the top one times 2 and the bottom one times 3. If you were going to cancel x, what would you multiply by?
Negative 5 and 3.
6x minus 12y minus 4 equals 0. And this one will be 15x plus 12y minus 3 equals 0. Add them together, so 21x minus 7 equals 0. So 21x is 7. Divide, and x is 1/3. Plug that back in. I'm going to go with the first one because 3 times 1/3 is nicer. So we get 1 minus 6y minus 2 equals 0. So negative 6y minus 1 is 0. So y is negative 1/6. And if you thought you had done something wrong, what would you do? Plug them back into both and check yourself. All right.
Okay. That's right.
You found it?
All different answers.
Oh.
I
You drop a
can-
negative or something?
Yeah, I dropped a negative.
And that will throw off your whole other variable.
I got positive 1/6 and put it in for x and got 1.
Yeah. All right. So sometimes we're going to solve this. All the ones we've done so far were the case where the two lines met in a single point. If we solve them and they never meet, what do we call it? Inconsistent. And I will say, like in the directions, identify any inconsistent systems. So let's start looking at some where the atypical cases, they don't just meet in a single point. So the options then are either they're the same line, in which case we're going to have to talk about how to write our answer, or they meet at a single point. So if I were solving it, we do it like normal. So substitution or elimination. Let's say I wanted to eliminate y. So I would have to take the top times, so I get negative 4x minus 2y equals negative 10. Positive 4x plus 2y equals 8. When I add, my x's cancel and my y's cancel. So that just leaves us with 0. Negative 10 plus 8 is negative 2. Does 0 equal negative 2? No. So what does this mean? Inconsistent. There are two things I want you to write. The actual solution, they don't meet, so it would be no solution. And then my directions said identify an inconsistent system, so I want you to write inconsistent as well. So the actual answer is no solution, they never meet. That's called inconsistent. Next problem. Same. What? What's wrong with that? It's beautiful. Everybody likes fractions. So, if you're good with fractions, you can probably look at this and figure out what to multiply by if you wanted to say cancel your x. 18. How'd you get it? Yes. You would basically have to multiply the 3 to get rid of the 1/3, and then we need another 6. So 6 times 3 is 18. You can also get it by dividing those coefficients if you're not sure. Or if you were just super confused, what could you multiply by to get rid of all the fractions in the first one? 6. So if you wanted to multiply everything by 6, so you didn't have fractions and then multiply by something else to eliminate, you can do it in 2 steps if you need to. But since you recognized it was 18, we'll just go with that. So 1/3 times 18, that's 18 divided by 3, so that would be 6x. 1/6 times 18, so 18 divided by 6 is 3y. 2/3 times 18, so 2 times 18 is 36, divided by 3 is 12.
Oh, look at that.
It's almost like I did that on purpose. Alright, so when we add, everything cancels over here, so we have 0. 12 plus negative 12 is 0. What does that mean?
That's it.
Yes, that's infinite solutions. They're the same line. Now, this is the one thing that we're doing differently than how you did it in the past. So you used to just write infinite solutions, which is true, but is every single ordered pair that I give you going to be a solution? No. What ordered pairs work? The ones that are on the line. So we have to describe those somehow. Your directions will tell you. If I want it with y arbitrary. Okay. If I say y arbitrary, that means we are going to keep y. So we know an ordered pair is xy. Y is going to be our variable. We have to come up with an equation for the x spot. So we just go back to our original system and we're going to solve for x. So if I wanted to take this one, I could add over my 3y. And then what would we have to do? Okay, I'm going to take everything divided by -6. So y is 2. 3 divided by -6 is -1/2 y.
It's
Oops.
X.
Yep, I switched my caught it at the same time you said. So in place of the x, I would put 2 minus 1/2 y. So that's a formula for how to find all the points on the line. And I kept y as my variable because my directions said to do it with y arbitrary. So if I said to do it with x arbitrary, we would have kept the x, and we would have to go back and solve for y in the equation and get rid of that. Any questions there? Okay, I'm going to give you guys a problem to solve. You guys do substitution or elimination? Okay, either way works. Okay, so you took the first one times the -2, so -2x minus 4y equals -8, and positive 2x plus 4y equals positive 8, and everything cancels, so 0 equals 0. I said y arbitrary, so that means they're infinite solutions. We keep the y, we just solve for x in the first one, so you can subtract, so x is 4 minus 2y. Are we good? So tomorrow we'll look at nonlinear ones. I want you guys to practice this today before we move on, so it's Math Excel. There are some questions that says to use substitution or use elimination. I know I can't really verify which method you're doing, but make sure you're practicing both so that you know them as we move forward.